Okay, Geometry, Chapter 2, Section 6, Proving Geometrical Relationships. So we've proved using algebra, and so now we're going to look at just a couple of different concepts. So just like at the beginning of the chapter, we're going to look at a few more theorems, and we're not going to focus as much on the definition of those theorems, but just the fact that they exist, and we'll be using them because you will see they are very very common, and we have been using them already. So let's start with theorem 2-3 or theorem 2.3. I'm going to call them 2-3. Actually, I should probably call it 2.3, just so it doesn't get confused with chapter 2, section 3 or anything like this. Okay, and this is going to be the right angles congruence theorem. I'm just going to call it right angles congruence. Anything that we do, well, whew, my spelling just got really good right there. Congruence, there we go. And we won't throw theorem on there because we know they're all theorems. Basically, it's saying all right angles are equal. So right angle ABC, let's say we had something like this. And I'll make sure I get that drawn right. And it looks off to me. I'm going to go back, do it a little bit longer. There we go. So let's say we have these two right angles here. And this is A, B, C, and D. Then the right angles congruence theorem would say that angle ABC is congruent to angle DBC. Again, a lot of this is using the logic that we already know. It's just we will have to identify it in proofs and different statements and reasons. So 2.3, the right angles congruence theorem. The next one is going to be, okay, I bet you didn't figure that it was going to be 2.4, but if you did, that's cool. So this is the congruent supplements theorem. And this is going to state, let's see, do I want to draw an example of this? Let me put it in writing. If two angles are supplementary to the same angle, I'm going to put that in caps, then they are congruent. Again, kind of makes logical sense. Well, not kind of, it does make logical sense. But again, we can use this theorem in our proofs. So if I had something like angle 1, plus angle, let's use an example that was in our book, I believe. Angle 1 plus angle 2 equals 180. And then if angle 2 plus angle 3 is 180, so if 1 and 3 are both supplementary to angle 2, then that means that angle 1 is congruent to angle 3. because they are supplementary to the same angle. Our next one is going to be 2.5, and that's the congruent complements and you can probably see where this one is going. And so I'm just going to use an example on this one because we went through the wording on 2.4. If angle A and angle B are complementary, and angle B and angle C are complementary, then angle A has to be the same or congruent to angle C. Two angles complementary to the same angle must be congruent. So that leads us to the final one, and that's going to be 2.6. And 2.6 is the vertical angle congruent theorem. And the vertical angle congruence theorem just basically states that vertical angles are congruent. If two angles form a linear pair, then they're supplementary. Excuse me, I'm sorry. If two angles are vertical, then they are congruent. I was looking at the wrong thing. So if I have this and this, and this is angle 1 and this is angle 2, then obviously angle 1 is congruent to angle 2. So using our vertical angle congruence. So let's put it all together. Let's find some different things that we can use, some different examples we can use this for. So let's just take that one. Let's go with the vertical angles, and let's say that I have something that looks like this. And I have that one of these is 3x plus 1. And that this is 148. Then just using my vertical angle congruence theorem, we've got 3x plus 1 equals 148. And we could solve for x. Whoop, minus 1. So that's 3x equals 147. Divide both sides by 3. And that's going to be 49. So let's take a look. Let's find a proof. Okay, let's take a look at a proof that doesn't have any blanks to fill in, that we have to start it and finish it all ourselves. This is actually number 21, found on page 105. Let's write that down. Page 105. And so we're going to go ahead. We've been given some lines that have another line that intersect. So if you will follow along with the actual diagram that's in the book, that will be great. And that'll save me some space so I don't have to flip back and forth between the screens. And so we're given that QRS and PSR are supplementary. Our goal is to prove that QRL is congruent to PSR. All right, so what we're going to do first, because that tells us they're supplementary, is we're going to go ahead and state that angle QRS plus angle PSR equals 180 degrees. And again, that's just by definition of supplementary angles. Supplementary angles. Okay, then step 3. Since QRL and QRS form a linear pair, that makes them supplementary as well. So we're going to say QRL plus QRS is also 180 degrees because of supplementary angles. I guess I can make that angles. There we go. So now you'll notice that QRL and PSR are supplementary to the same angle. In steps 2 and 3, you'll see that QRS is there. And we know by definition, by the theorems we were just using, that's going to be theorem, I'm looking back and just to check my numbers right. That's going to be theorem 2.4. So theorem 2.4 helps me out a lot here because I can now say that QRL in step 4, make sure we're on a pen there, that angle QRL is congruent to angle PSR. And that's because of postulate 2.4. Pardon me. Postulate 2.4 is my congruent supplements theorem. I'm just going to write congruent supplements. Okay, so a 4-step proof. We went with the given. We had supplementary angles twice. You could also combine step 2 and 3 if you wanted to put QRS plus PSR equals 180 and QRL plus QRS equals 180 in the same one. You're more than welcome to do that. I just stretched it out just a little bit. So that's number 21 on page 105, and that brings a close to this chapter in chapter 2, section 6, proving geometric relationships.